Much of the rest of this chapter is going to talk about different types of quadrilaterals or four-sided polygons. And today in particular, we're going to learn about some properties of parallelograms. You've probably encountered parallelograms before, but we're going to learn some more specifics about them. A parallelogram is just a quadrilateral that has two pairs of parallel sides. If you look at that picture, you'll notice that the top and the bottom are parallel and the left and the right are parallel. You always have two pairs of parallel sides, and you'll see the arrows in the pictures to show that you have a parallelogram. There are a bunch of properties that will always be true when we're looking at parallelograms. Now, we're going to basically just talk about the existence of these properties, but if you wanted to prove them, what you would end up doing is dividing the parallelogram up so that you have some congruent triangles. You did something very similar to that back before Christmas when we were learning about just rules of parallel lines in general. And it turns out that really about all we're going to do is extend those same properties. First one is that opposite sides of a parallelogram are always congruent. If you have a parallelogram, the top and the bottom will always be the same. The left and the right will always be the same. The opposite sides have to be congruent. So, like you often do in your book, you're going to see problems that look a lot like this, where you'll see things marked off, and what you're supposed to do is figure out what's x and what's y. If I wanted to find y, I might just realize that y plus 3 has to be 12, so y must be 9. You could also figure out that 6x minus 7 equals 2x plus 9. You would then get your numbers on one side and your variables on the other. I'm pretty sure you would have 4x equals 16, so x would have to be 4. It's also true that the opposite angles of a parallelogram are congruent. The opposite sides are the same, and the opposite angles have to be the same. So, like here's a picture, you notice that we have 110 across from 110, 70 across from 70. If I wanted to find what's up in this particular quadrilateral, this particular parallelogram, I know x has to be 80 because, again, the opposite angles have to be congruent. And you could also figure out that the other angles are going to end up being 100 degrees in order to make the 360 that we have to have all together. So x is 80, w and y both end up being 100. Also true in parallelograms is that the diagonals bisect each other. They cut each other in half. If you draw in the two diagonals going across a parallelogram, they always end up dividing each other equally. And so again, if you saw a picture like this, you would know that x plus 40 must equal 2x plus 18. And again, you would want to get your numbers on one side and your variables on the other. I think when we solve this, you're going to end up with 22 as what x would have to equal. Same kind of thing in here. I know that y plus 7 would have to be 20, so y must equal 13. And since x plus y has to equal 16, if I know y is 13, x must be 3. So again, we're looking at all the different rules that come up with parallelograms. And what it really boils down to is, again, things that look like they're congruent are congruent.